Hello everyone. Today I'm going to talk about modernizing the monolithic architecture to container-based architecture. Good morning, afternoon, or evening, depend on the location you all are joining. Unfortunately, I can't present this session in the real time, so I'm pre-recording this session. Please contact me via Twitter or the LinkedIn for any feedback and the questions. About myself, Vinay Kumar, I'm an Oracle ace from 2014 and I'm based in Netherlands. I'm working for an insurance company as a global enterprise architect in application and integration architecture. I'm a frequent blogger on Oracle Fusion Middleware, cloud, open source technologies. I have also authored a book on Oracle Web Center Portal. As part of the Oracle ACE program, I would like to add few details of ACE program. It has three tiers: Oracle ACE Associate, Oracle ACE, and Oracle ACE Director. And if you want to be part of that Oracle ACE program, please go to the respective link and check, and you can nominate yourself or someone you know. You can also do a nomination, and then you can also be part of this very nice Oracle ACE program. This is the agenda of this talk. I would be talking from what is monolithic application are and why we should modernize the architecture. What are the core principles and the patterns for the microservices architecture, and how we can modernize a monolithic app to microservices or container-based architecture. We are also going to show the high-level modern architecture, especially based on containers, and how we can really divide a monolithic application as an example to build into a container-based architecture. Monolithic systems are created in the same code base, and it's a self-contained and independent from each other computing application. The design philosophy is that the application is responsible not just only for that particular task, but can perform every step needed to complete a particular function. Monolithic systems are normally created in the same code base. This code base is divided into multiple modules according to the business or technical features of the system. With increasing size of the software system, the complexity of the system keeps growing. This could make the code base difficult to maintain and scale, and that might be one of the problems of a typical monolithic application. Let's take an example. Normally, in any monolithic application, we do have client, business logic, data access layer, and the database. In a typical client server architecture, a monolithic product lives on the server where it handles the HTTP request, execute logic, and interact with the database. It contains a single executable that performs all of the server-side function of an application. Monolithic architecture is built on one large system and is usually on one code base. Monolithic application is tightly coupled and entangled as the application evolves, making it difficult to isolate services such as independent scaling or the code maintainability. Another example, which we can say, especially in the Oracle Fusion middleware, where everything runs under the WebLogic, where we build the data services, business processes, or orchestration, and also the user interface. And maybe this is the time where we should look at some of the modern technologies and we can modernize our architecture. But let's talk about the traditional server-side application architecture. In a traditional server-side application, we have the basic server-side app, a client-side where the user make the input and the request. These requests are then sent to the server side where they are treated accordingly. After the presentation layer or the front end, we make a request to the backend side where the logic is present and where we can send the request made by the backend to the data layer where they can cache the requested data from the database and send it back to the front end. This is a monolithic. This is and because all the logic is contained into a single file in a way that it is only accesses the single database. But is all the monolithic application are bad? Maybe not really. Choosing a monolithic architecture, I mean, as an organization or as an architect or a developer, you need to decide whether you are still happy or you should change to the new architecture. And why we still wants to be on monolithic architecture, there might be few reasons. If you are a part of a small team and if you're a startup and your team is small, you may not need to deal with the complexity of the microservice architecture. A monolithic can meet all your business needs, so there is no emergency to follow up the hype and start with the microservices. Or you might have a simple application, a small application which do not demand much business logic, superior scalability and the flexibility, work better with the monolithic architecture. If maybe you don't have the microservices skill set or the expertise. Microservices architecture require profound expertise to work well and bring business values. If you want to start a microservices application from scratch with no technical expertise in it, most probably it will not be the payoff. Another reason to stay in the micro monolithic application is you want to do a quick launch. If you want to develop your application and launch it as soon as possible, a monolithic model is the best choice. It works well when you aim to spend less initially and validate your business data later on. Why or why not modernize the monolithic app? We can really see there are a lot of benefits with the monolithic apps, and then we do also have some drawbacks. The simple approach has in monolithic has a limitation in the size and the complexity. Application become too large and complex to fully understand, and make changes fast and correctly can be difficult. The size of the application can slow down the startup time, and we also need to redeploy the entire application for each and every update. Impact of a change is usually not very well understood, which leads to the extensive manual testing. And also one of the main drawback is continuous deployment is difficult. Some monolithic application can be difficult to change. This may be due to the technology challenges or maybe due to the regulatory constraint. Some components in use today may have come from the different suppliers, making change difficult or impossible. It can be both time consuming and costly for the organization to go through a complete audit process. Often organizations continue to invest in older application much longer than is appropriate in the belief that they are saving money. It is possible to evaluate what is a monolithic application does to learn if some individual functions can be separated and run as a smaller independent services or an API. This can be implemented either as a cloud-based services or a container-based microservices. Rather than waiting and attempting to address the older technology as a whole, it may be wise to undertake a series of incremental changes to make enhancing and replacing an established system more acceptable. Although microservices bring many benefits for the large projects that have a lot of developers working on them, the smaller projects are usually built with monolithics. Monolithics are cheaper and developed to launch because they consist of a single code base. That's why transition to a microservices should be well planned, well understood, and decision based on the need and the power of the company. Companies that are growing should seriously consider microservices as an architecture because the common reason teams migrate to microservices are scalability and the productivity challenge. Projects that are growing require more developers, so allowing them to focus on a single service of the application make things much more easier. If they are working with a monolithic architecture, they all have to access the same code base. In this case, the smallest change can disrupt the communication between the teams and change the entire application. The need for frequent testing is bigger so that the conflict can be avoided, as this slows down the entire release process, reducing the productivity of the entire department. Microservices eliminate all these issues. They allow immediate release as the CI/CD pipelines are easily integrated. Deployments can happen thousands of times per day. All the same time, the application is running as usual as it consists of many different small components. Microservices. What exactly are the microservices? Microservices are the software development technique that arranges an application to a collection of loosely coupled services. That's the easiest definition I can really find. The primary motivation of microservices, number one, software. Primary motivation for the microservices is that the software is eating the world. Every company needs to become a technology company. Software technology is central to their products and to their services. And combined with the fact that marketplace within which companies operate in many industries becoming much more volatile, uncertain, the new competitors emerge out of nowhere. And what that actually means that business need to innovate at much faster pace in order to deliver new products and the services and remain competitive in their market. And sorry, let's go back. One of the common reason is we really need to understand, or the organization really need to understand what innovation and the technology bring to their business, and they can really do, I mean, if the way they are doing their business, they can really bring a lot of innovation by the using of new technologies or the microservices based architecture. If we look at the benefits and the drawbacks, there are many benefits which we already talked. And one of the main benefits, I think, microservices architecture, which can be a solution for companies that need to quickly implement new changes and scale their business, and that need a large system that can be broken down into smaller modules in order to develop them autonomously later. And there are a few advantages of microservices architecture. Scalability is one of them. Each microservices can scale independently without affecting other microservices. Thus, it definitely serve an advantage over monolithic application, wherein a lot of resources are wasted for scaling unrequired services, since they all are packed together into one single deployment unit. Availability. If one of the services fail, the other microservices are highly available, and the failed microservices can be rectified very quickly with the minimal downtime as well. That it definitely serves as an advantage over the monolithic application, where the entire application has to be brought down. Fault tolerance, agility, polyglot persistence, maintainability, cloud agnostic or the software technology agnostic are the some of the key advantages which we can also say with the microservice architecture. We have the faster development and the deployment. Unlike a monolithic application, code changes in microservices can be done very quickly with the changes in business requirement, which result a faster development cycle. Microservices also cater to a single business functionality. Amount of code base is reduced considerable, which make way faster to the faster deployment and the clear separation of the business concern. Each microservices have their own boundaries and caters to the unique business functionality, and thus there is a very clear separation of business concern between each one of them, and thus each microservices can be built in a very robust way. If we look at the difference between the microservices and the monolithic architecture, and this is a clear difference between both the architecture, and we can see each microservices is independent to each other and contain their own database, and each microservices can also have their own language or the technology. It is isolated. They also have the isolated deployment development unit which act as a single atomic unit, and we can deploy each microservices as part of the containers which can follow the whole, I mean, teams development teams can be different, the deployment pipelines can be different, and they are not independent or they are not dependent to each other. On the other hand, we already said that monolithic architecture which contain the user interface, business logic, and the data access layer into one unit, and that make things much more complex. Where you stand, I think this is one of the beautiful slide where you should understand where you really stand in terms of the technology, in terms of the process, or in terms of the people. Whether you still have the centralized team, whether you have something called center of excellence, whether you have the isolated teams, decentralized teams, or the self-organization team. Are you still working on the silos or the monolithic application, or you implemented, you already introduced SOA-based architecture and you are using with enterprise service bus, or you still move to the API-driven architecture where you have introduced, you have already started the journey to the microservices and you have introduced an API gateway on top of the ESP, or you still working define your domain-driven design and so on. So this is in, I mean, if you look at this example, you are really can find an incremental approach from the monolithic to the microservices based architecture. And on the contrary, we can also see how the people and how the process are really defined to manage the expectations to make this journey possible. And now if you look at the close look of the microservices architecture, we can really see the difference here that each microservices are developed in a different technologies. They have their own database. And one of the new thing which you might see here, we do have something called container orchestration. Container orchestration is nothing just to manage the request from different containers and which do the orchestration. Normally in our traditional or the SOA world, we have something called people, which or the SOA suite, which do the orchestration of the different services. And here we do have a container orchestration. And then on top of that, we do have an API gateway, which will act as a proxy layer. And then we by using an API gateway, we can access those different clients or the omni channels by which then data can be accessed. Is the change really worth it? Why I should be more focused, or why I should worry about microservices? I'm happy. My monolithic application is working fine. Why I need to worry about this change? Enterprises that have made the move towards the adoption of microservices-based application architecture have said or commented their IT costs are often reduced. They are also often point out that once their team mastered this approach, it was far easier and quicker to add new features and functions when market demands change. So as a developer, as an architect, or as a leader, IT leader, you really need to think whether you really have this requirement and you are ready to you ready to be the part of this journey to the new architecture. Everything comes with a price, so nothing is free in this world, and microservices architecture can be also quite complex. There are some of the architecture patterns you would be required to implement microservices or the container based architecture. Some of the important patterns are maybe the service discovery, the messaging, the circuit breaker, event driven architecture, API gateway, container orchestration, logging and health check. So it's not only the technology change, but it's also a cultural change, or it's the organizational change. You also need to make some changes within your organization, that the way the teams are developing, the way DevOps is working, the way operational team is working. It's the change of the organization, and that's why you can say it's the real transformation. On the other hand, I mean, so if you are a part of this journey, if you are developing the microservice architecture, you have to look at these patterns, at least these list of these patterns, and you can really check whether you have all the capabilities to make sure you have all capabilities to enable this microservice architecture. Now we will talk about microservices core principles, and and I have listed few of them, and I will go one by one. Single responsibility, which can be about the context. Each microservices must cover and be responsible for a specific feature or functionality or an aggregation of cohesive functionality, encapsulating a functional domain. And that's one of the key requirement or key principle for a microservices. Domain-driven design. Microservices are organized and built around the encapsulated business capabilities. Each business capability represents what does a business does in a particular domain to fulfill its objective and the responsibility. Incorporating domain-driven design allows the architecture to isolate system ability into various domains. Designing around real-world domains translates to software that represent the real-world problem you are trying to solve. Encapsulation. A service should be only consumed through a standardized APIs and should not be exposed as internal implementation details. It might be composition, business logic, persistence mechanism to its consumers. Service discovery. Services should be never exposed directly to a consumer. Service should be never made aware or the dependent on the exact location of the service. They should instead use some form of indirection when locating or invoking services. Decentralization. Microservices embrace uh, Microservices embrace loosely coupled resources. To achieve autonomy, an organization should strive to push power out of the center. Organizationally and architecturally. Each service handling its own responsibility should be favored over having a single orchestrator that hold all the business logic in one place. Within a microservices environment, there should be no resource centralization. Independently deployable. Microservices should be independently deployable unit as a component in the application ecosystem. This principle enables a change in one service to be deployed without requiring any other services to be deployed. culture of automation is key in the microservices architecture. A standardized API mechanism with a published contract. A service interface should be well defined, standardized, and the widely adopted mechanism that is published and available to its consumer. And that's why I always recommend to follow the API first approach, where the API definition is built before the implementation, and those API definition can be validated via multiple iteration to their consumers, and they can start work on the APIs by looking at the API definition, and even when the API implementation is not completed. The API is consistent across other microservices to increase reuse and avoid breakage. Using a standardized and widely adopted interface mechanism allows the service to be more easily consumed across different systems and the languages, and by far more consumer in a shorter period of time. Highly observable. In a microservice environment, high CPU usage on one container or instance does not necessarily imply an error. Informed systems held decisions are based on aggregated data. A service should be easily monitored and proactively alert in the event of detectable risk. Service should be developed in that way with the observability and monitoring in the mind. Resiliencies and the failure isolation, and we also need to imply the right security mechanism, which might be an OAuth as a protocol to all the microservices via using API gateway or the certificates and so on. Now we do have a monolithic application and we want to modernize this. How can we do it? The question really here is, how do we get from our monolithic to the microservice architecture? Now we understand the advantages of it, and now we want to build a microservice architecture. And one of the best practices that sort of evolved over the years is don't do a big bang rewrite. Never try to rewrite your monolithic application at once. And that's where you decide where we are going to start from the scratch. Should you do start from the scratch or completely re-implemented system? That usually does not go very well normally. Instead, what you want to adopt is an incremental approach, and the pattern you use is normally Strangler Application pattern, which we will talk in next slides. The big bang rewrite guarantees is only a big bang. So the best way is to go incremental. We want to adopt is an incremental approach, and the pattern we will use is known as the Strangler Application. So by that time we will have the experience, and we also understand our business domain to make sure our microservices boundaries or the domains are correctly defined, and then we can also optimize with the time. When we say the strangler pattern is quite a good approach when we try to slice down or decompose our monolithic application. To enable trunk-based development, we need to renew the architecture basis of our existing application. Fundamentally, we have two ways. One, we either build a new version of the application or swap one for the other or change the structure on the fly. And that's what we call as a strangler application pattern or the approach. It reduces the risk associated with the transforming application and allow to continue developing new functionality in parallel with the transformation itself. In this approach, existing functionality updated slowly. New functionality should be developed in APIs, build an abstraction layer, and have a state of coexistence of modern and the monolithic architecture. And at one moment of time, we can really transform the whole architecture. And to implement this picture, where we will also have a state, a complex state where our database states need to be synchronized together, because at one moment of time we will also have some sort of a new functionality which have been driven or designed into the microservice based architecture, and we also have a monolithic application which is still running, and that's a state of a coexistence. There we really need to maintain our database, and those database transition also need to be synchronized, and that's why it's a coexistence. But at one moment of time, everything will be in a microservices. When we try to slice down, it's good to have an additional abstraction layer, which might be an API gateway, which enables to reroute some of the existing functionality into the new modern architecture services or the applications. So when we talk about the Strangler application pattern, it comes into the four parts. We need to build the abstraction layer. We need to stop digging the grave. We don't need to need to work on the existing module. We can rewrite and replace existing features, and we need to eliminate. In part of the abstraction layer, the first thing we need to build an abstraction layer. You expose a number of APIs through which you access the functionality availably with the monolithic application. Choose the type of the APIs you expose carefully, as they are the APIs you will continue to expose when your application is transformed. Use a web services approach or the APIs approach. These APIs become the way to invoke the functionality available in your application digitally. Doing this is really important. You may want to freeze the development of the application for a month or two till you have a clear definition of the abstraction layer. And in this way, we can really, and that's the basic step to start your transformation. The next point is stop any development on the monolithic. That functionality is available and no longer change. Make sure it is called via an API. This implies you may have to change this thing other application that interface with this one. What you are doing in isolating the monolithic and only access via the APIs. Any new development is done outside the monolithic and interacts it through via the abstraction layer. Build the new functionality following the SOA principle, or even better, follow the microservices principle. And in that time, we can also have a 12-factor application patterns. We also need to look that your new functionality is loosely coupled with your monolithic and with other application function. It does one clearly defined functionality and it is autonomous. Replace existing functionality. Here we can start rewriting or replacing the existing functionality into the new modern architecture. And the last one is we really need to remove the release cycle. By transforming your application into a series of loosely coupled functional modules, not only do you enable them to scale up and the scale down to address varying needs, but you also enable the release of the individual modules, making the traditional release process obsolete. What if you no longer need to plan a release for weeks or the month? Having a team working around the clock over a weekend to install the new version and maintaining staff on the standby rollback if required. As a functions modules are loosely coupled, you can now just replace one module in the series. And if you make your modules error proof and capable of handling the absence of surrounding functionality, you have the opportunity to bring the functionality online in matter of times, and you can also remove the release cycles. As part of the Strangler, we have few patterns like, as we mentioned, transform, create a parallel new site or the application which might be running in any cloud or maybe on premises, but it need to be developed in the modern approaches. Coexist, leave the existing application or the monolithic application where it is for the time being, and redirecting from the existing application to the new one so that functionality is implemented incrementally. And start eliminating, remove the old functionality from the existing application as traffic is redirected away from the portion of that old application to the new application. How can we do that? Uh, the general sort of technique here is basically intercepting call to the monolithic, which are being implemented by some modules inside the monolithic, and then redirecting them to the implementation so that modules are a standalone service. And we are doing just for one module at one time until you migrated necessary functionality out of into the new server. And every time you move functionality into the services, you sort of moving its development from slow monolithic lane to a faster DevOps pipeline. And we can also have introduced the API gateway as an abstraction layer. Now, if we talk about microservices, domain-driven design is one of the common things, and we will follow it domain-driven design. Domain-driven design is an approach to the software development that centers the developments on a programming a domain model that has rich understanding of the process and the rules of the domain. Domain-driven design is a key and is as a necessary tool when designing a microservices, be it breaking a monolithic or implementing a greenfield project. Bounded contexts define the tangible boundaries of applicability of subdomains. It is an area where a certain subdomain makes sense whilst others don't. We do have domains which normally represent what an organization does. Subdomains can be a subset of a domain, and we always try to decompose into the subdomains to ease or to help into the modeling and the comprehension of the business. Bounded context is a central pattern in a domain-driven design. It is focused on the domain-driven design strategic, which is all about dealing with the large models and the teams, and to understand the models and their relationship and dependencies. So if you want to decompose or slicing down the monolithic into the microservices, we have to identify the bounded context in our application design. A and bounded context is a shared conceptual framework that constrains the meaning of number of entities within a larger set of business models. For an example, in an airline application, we have a flight booking as a module, what can be a one bounded context, while airline loyalty program can be another bounded context. But even they will share the information or they will share the context as a flight, and the way in which those terms are used and different or the message can be shared across the different bounded contexts. Find out the bounded context that is the smallest and the least costly to refactor. Always find out the bounded context boundaries to the smallest and least impacted so that you can really understand the business and you can define the boundaries. And then conceptually plan out the microservices design, draft your microservices design, come out with a rough resource URL structure, and come up with the dependencies or the responsibility of that microservices when we try to do the mapping with the entities, aggregate, and the service patterns. And when we talk about the dependencies and the relationship, and I think it's one of the good approach, we will start from the user interface. We need to understand from a user interface screen how many services we are calling or how much modules we are calling and how those relationship dependencies are exist, so that it will really help to do a mapping between your entities, domain, subdomains, and the aggregate. Follow the principle of least surprise to the related aspect of the model manipulation. So always try to make things much more simpler and do not go for the complex thing. Size your chunk. Plan, as we mentioned, always decide the right size for the chunk or the series of services it should be done, and whether we want to develop the whole chunk at one time or we want to define or develop a new series of services. That might be a good approach. Okay, let's take an example of a traditional banking or the financial systems. And whenever we talk about a financial system, we will have a lot of terminologies came into our mind, which might be customer, account, booking, statement, credit, cards, and so on. Imagine, and we already have a traditional banking system monolithic app, and we want to say now we want to modernize into a microservices based architecture. And the first step is really to understand the bounded context or the boundaries. It's quite complex, and I think there you really need to interact with your architects, product owners, business people to understand how those relationships work. And having a workshop to understand those things, you might come up with these things and you identify some of the candidates for the bounded context. So you can say customer, card, accounts, and the credit can be good candidates for the bounded context, and other related topics can be good for the subdomain. So now we have identified the bounded context, and now we can do further on. But is it good enough? I mean, are we happy with it? Maybe not. We should always decompose our bounded context much further, and then maybe try to find out the subdomains, and subdomains can be a good boundary for our microservices, and also to understand the relationship and the dependencies between them. So if we see a subdomain, we are already identified the boundary context. Now we need to find out the subdomains and supporting subdomain or the context or the aggregation. The aggregate is when we say aggregate is just a design pattern mentioned or introduced by Eric Evans in his book Domain-Driven Design. An aggregate defines a self-contained grouping of entities which is treated as a single atomic unit. So there might be a few pattern or some action which might be in relationship between customer and account, and it's a self-contained group of entities which perform a single unit of task. A change to any of these entities is considered to be the change of the entire aggregate. Every aggregate is made up of the following a boundary. This is a clear definition between the entities that are the part of the aggregate and those that are not. A number of entities, those entities are the business object contained within the group, and the root. Every aggregate exposes exactly one of its entities to the outside world. Object outside the aggregate can only reference to the aggregate root. They cannot directly address any other entities within that aggregate. So if we say an aggregate, it will have an boundary, a number of entities, and a root object. Root object normally interact with the outside world or the boundaries of the domain. And here we can say, okay, these might be good candidates for the subdomains, and the entities, or the context, or the aggregation, which we just talked about. Okay, a microservices is a boundary context. Can we say we have identified the boundary context and now we have 4 microservices? Maybe not. So a microservices is a boundary context, but not the vice versa. So not every boundary context is a microservices, but a microservices can be a boundary context, and subdomains should and can be further decomposed. Aligning boundary context with this business subdomain is another popular approach for decomposing system into the microservices. However, even subdomains can be decomposed further. Hence, aligning boundary context with the business subdomain is not a approach for decomposing a system into a microservices either. Can we see a subdomain into a microservices? Maybe or maybe not. And I already mentioned that microservices can be a boundary context, but not every boundary context can be a microservices. Now we have identified the domains or the boundary context, and now each domain interacts to each other via the events. And pub and sub is a mechanism to talk or interact via the events. Event streaming is a good example. Find out the right information to pass as an event across the common boundaries, which normally called as context or the event. In a domain-driven design, domain events are described as something that happens in the domain that is immutable and that already happened in the past, and that's not a command. That's an event. And it important to the domain. It is really relevant for the domain expert and the product owner who can identify those events. Such events typically occur regardless of whether to what extent the domain is implemented in a software system. They are also independent of the technologies. Accordingly, domain events have high value semantics, which is expressed in the language spoken by the domain expert. For example, some of the example of the events: a customer has registered, an order has been received, the payment deadline has expired. In this scenario, where one of the event can be when a new customer created, it need to make a new account to the respective customer. So when a new customer is created, we have to pass this information to the account domain so that the account domain can be also created respectively. And respectively, we also need to validate the customer rating to be evaluated and the validated. Okay. Now we do have a big monolithic app. I mean, a normally typical financial system for the same example as the monolithic, which we have a customer, cloud account, or the credit, all the part of in as one application, and is deployed as a single WAR file in some application server. If you want to make the change into a customer module, you need to deploy the whole WAR file, which is slow and requires testing of the full application, which we don't want. And now we want a microservices architecture. How can we do that? Once we try the incremental approach, we build each functionality as part of the service or an API, and now also transform the top layer as APIs, and there we also introduce an API management or API gateway layer also for the abstraction layer. And this can be a good example because even if we see in Oracle Fusion middleware, we have ESB, which might be an Oracle Service Bus, and we will also have an API gateway on top of that. In Fusion middleware perspective, Oracle Service Bus can be also used with the API gateway in the same if you want to modernize our if you want to modernize our monolithic application. It is a good way to divide the monolithic into the boundary contexts and then define the services or an APIs, and we can also identify the right domain, subdomain, and we can build a service. Still, we can run into the application server, we can have it transform into the APIs and use an API management layer, and we can slowly reroute all our existing functionality as part of the services or an API. Now we have transformed into the new services. We try to identify the domains, subdomains, we understand the dependencies. Now we have a single boundaries for the each module. And once we have that, the next thing what we can do is to use these services into new APIs and deploy as a container, independent container. Each container manage the orchestration of each container manage the respective APIs, and we also required a platform which manage the orchestration of these containers. And these domains can interact with the events, and that's why we also need to introduce the event management, which can work on the problem sub mechanism. And we also have the API management, and that is more like a high level architecture of a container based architecture. And on top of that, we can have an client or the omni channels which can interact to these APIs, and we can build a new architecture. And each module is so independent, we can develop or scale down or scale up respectively depending on whatever our needs are. And so if you say now these are some of the steps mentioned to plan to decompose the monolithic application. First, we analyze the monolithic design data. We really need to understand classify the data into the 3-tier layers. Then we also need to map layer by layer as sort of a class type, and then we can come up as a class layer mapping table as an artifact. The next step is we need to understand the candidates for the right bound context, domain, subdomain, microservices. Under the class relationship and the dependencies, persistent strategy should be also discussed with the relevant product owners. Extract the microservices and the map to the respective entities, and also find out the support context which goes across the boundaries of the microservices. The third step is implement the microservices. And the fourth, you build and deploy your microservices. Build a separable deployable unit, and automation is a key here. We can come up with a generic template to build a script for the container deployment. Service discovery implementation is a key here. So I think it's a good way to follow this approach to go step by step and come up with the artifacts delivered. Summary. So monolithic is not always bad, but if you have the requirement to modernize your architecture, this is the right time to do it. Don't rewrite fully, change or follow the incremental approach. Make the split right, make the right boundaries as the boundary context, decompose your domains, subdomains, and the boundary context further. One boundary context is not a microservices, but one microservices can be a boundary context. And in a boundary context, you might have one or a few other microservices. Services should follow the single responsibility principle. Services should also conform the common closure principle, things that can change and the pack together. So if you have a business process which there are few things which combines or quite related to each other which changes and pack together, then you should design your business process and the microservices accordingly. Have an independent deployable unit as a container, and API container management and event hub is required to introduce the new architecture. Feel free to give me any feedback, doubts, or the questions via Twitter or the LinkedIn. I'm happy to help there. Thank you very much, guys. Take care.